Right, hi everybody, welcome back again. I want to move on today to topic 3.3, the title of which is Threats to Biodiversity. You'll see from the keywords above my head, I want to split it into basically two sections. The first one, we can look at what the actual threats are. You know those ad nauseum by now. The 5 ways that humans affect biodiversity globally are alien species introduction, overharvesting, islandization, habitat destruction, and global pollution. And then I also want to look at what makes some biomes or some ecosystems more able to recover than others. We'll look at inertia, resilience, and diversity under that topic. We could look at some case studies here, but I think I'll do that in a second video where we look at particular species, especially that are under threat. Let's move on quickly to the syllabus. It looks like a lot of writing, but there's really not that much for us to get through in this one, I don't think. First of all, this first bullet point tells us that we probably radically underestimate the number of species that are actually on the planet. We don't really have a good idea, within a few million, how many species are actually on the planet. We know that species extinction rates are rapidly increasing, and that points to a major extinction event that we're actually living through now, and obviously the source of that is humans. We'll talk a little bit about the IUCN, the International Union of Conservation of Nature, their publication, the yearly publication of the Red List, which you might have heard of before, the Red List of threatened species. Basically, this is just an annual list of which species are under imminent threat of extinction. Quite depressing, actually. And then finally, I think we might talk about this a bit more in the classroom. The fact that the biomes that are really under threat at the moment tend to occur in the tropics, and those biomes basically occur in LEDCs. And we can talk about the conflicts that and the political conflict that either causes that or these LEDCs suffer because of the threats to these biomes due to exploitation, conservation issues, and hopefully the move towards more sustainable development. Now, under applications and skills, I want to do this in a second video, but the IB asked us to look at case studies of a species that's critically endangered, a species that's already become extinct, unfortunately, and hopefully we can finish on a slightly better note. Conservation success, where a species has been brought back from possibly the brink of extinction. But I'll look at that separately. It says we need to describe the threats to biodiversity because of human activity in one case study. I think I'll leave that to another video. Evaluate the impact of human activity on tropical biomes. I want to look at, as well as that, I want to look, like I've said above my head here, about why certain biomes are more able to recover than others, and why certain biomes, it doesn't take much to push them over the edge in terms of human activity to lead to big biodiversity losses. Okay, and then finally carries on from what I said before on one of these points above. Discuss the conflict between exploitation, sustainable development, and conservation in tropical biomes. Again, I think we'll look at specific case studies at a later point to cover that stuff. Okay, so first of all, I want to just look at that first point about why we don't really know how many species are actually on the planet. A lot of reasons for that. Obviously, there's a huge number. It could be anywhere between about 5 million and 100 million. One of the reasons we don't have a good idea of, even in the right ballpark possibly, is because there hasn't been one sustained effort to actually even catalogue the number of species we've actually recorded up to this point in human history. They all exist in scattered catalogues, handwritten notes in universities and museums all over the world. People have been doing this for hundreds of years, and there's never been one effort to make one database of all of the species we've actually discovered. If we don't even know how many species we've actually discovered, then we're not even close to discovering, to coming up with a figure of how many species actually do exist on the planet. New species are still being discovered today. Surprisingly, that includes some big mammals. I think in the 1990s, a new species of primate was discovered, spider monkey, I believe. We've probably named around 2 million species, which sounds a lot until you consider that there could be about 100 million species on the planet. Most of those species are obviously very, very small microbes, bacteria that we might not have catalogued. A lot of them might live in very inaccessible places, including right within the Earth's crust itself. Okay. Most species are animals and are terrestrial because that's where most niches exist in terrestrial ecosystems. 2/3 of all species live in the tropics, in tropical rainforests especially. A lot of unexplored areas there. And then this is just a little bit of my own thinking. Most species are not exactly flagship species or species that humans have a big interest in for a lot of reasons. Many are small, many are insects which people find very disturbing sometimes, or worms. These are nematode worms down here. Not exactly cuddly, and therefore not actually a draw for study or for people to get emotional about. Okay, so we don't have a good picture at the moment about what the world's biodiversity actually is, because we don't know how many species are, and we've not even discovered probably most of those. On average, as we've seen a couple of videos ago, we have a mass extinction event on the planet approximately once every 100 million years. Thankfully, I don't think we're really due for one very soon. There's been 5 in Earth's history that we know about. We did talk about that in a previous video, and the last one was the extinction of the dinosaurs 65 million years ago. However, if you look at the rate at which species are becoming extinct today, basically that rate of extinction is pretty much the same as they seem to be going extinct, as the fossil record tells us, after what we think was the meteorite strike 65 million years ago. It's just the causes of this rate of extinction are different today, and obviously caused by humans. In between extinction events, there's always a background extinction rate. We've talked about that in terms of evolution. Species come to evolutionary dead ends eventually, naturally, not even due to human interferences. We've seen that with a lot of species. When they become very specialised to a niche, they can exploit that niche very well, but unfortunately for them, what happens when the niche changes? They can't adapt, and therefore they do become extinct. That's called the background extinction rate, and that's always with us, regardless of what humans are actually doing to the planet today. Are we living through a 6th mass extinction event? Well, I've put a question mark there, but I don't think there is a question. The unpalatable truth is that we actually are. Here's the evidence for that. Mammal species, if we just look at mammals as an example, on average, one species in the fossil record we see lasts around 1 million years before it reaches this evolutionary dead end and then could be expected to become extinct. Obviously, this is a gross generalization. Today, we have about 5,000 known species of mammal, extinct and extant, living and extinct. So therefore, the calculations tell us that the background rate is about 1 mammal species every 200 years becomes extinct. If you look at what's happening today, in the last 400 years of human history, there have been 89 mammal species extinctions, and 169 species are currently on the red list as being critically endangered. Compare that to 1 species would be expected to become extinct because of background extinction every 200 years on average. The extinction rate is huge, and obviously it's been driven by human behaviour. As we said, 45 times the background rate. Are we therefore living through the 6th mass extinction event? I would say the jury's not out anymore on that. Okay, and I'll just left you with a little picture of possibly the most famous living biologist. I've talked about him before, E.O. Wilson. He's claimed that at current rates of biodiversity loss, in 100 years' time, your children could still be around by then, we will have lost 30 to 50% of the species alive today, which is a very depressing thought. Okay, in terms of disturbance, again, I've mentioned this already in terms of these keywords up here. 3 things determine how quickly an ecosystem can recover. Its inertia, how resistant it is to alteration in the first place. Its resilience, possibly the most important factor, which is its kind of innate ability to be able to bounce back from an event that could cause extinction. And then finally, the existing biodiversity, or the diversity we begin with. Okay, let me put that into a little bit of more, something a bit more easy to understand. Let's compare 2 biomes, tropical rainforest and grassland. Tropical rainforest has high diversity in the first place, has many niches. That's a kind of double-edged sword. First of all, this niche availability means that if some niches are hit by an external event, it could allow recolonisation, and it can allow, to some extent, the biome to resist this change. It also has high inertia, which is a good thing. However, it has low resilience. It takes a long time for a rainforest to recover, to repopulate these niches, and because of all these slow-growing species. A complex ecosystem has many ways to respond to disturbance, but in terms of rainforest, because it's got very thin soils, very low in nutrients, it takes a long time, as we talked about in terms of succession, secondary succession. It does take a long time for these ecosystems to become repopulated. If we compare that to a grassland like savanna, savanna has low diversity to begin with. To some extent, that gives it an advantage to be able to recover. It has low inertia, but it has high resilience. It takes a much shorter time for grassland to recover to change than it does with tropical rainforest. Grassland's a very simple ecosystem, very thick soils with lots of storage of nutrients, and therefore primary productivity especially can get back to normal very quickly. Obviously, this is a generalization because it does depend on the disturbance. With the rainforest, you expect local disturbances, and we've talked about this in terms of sometimes very small or fairly small local disturbances can be a good thing. They drive change, and therefore they drive evolution and natural selection, and it's one reason why we have all of these niches available in the first place, is because of all these localized changes. The big problem with human interference is it happens on a huge scale in terms of habitat destruction, and especially in terms of pollution, which now is global. Again, very unfortunate and very depressing. Your timely reminder of those 5 ways that humans actually interfere with natural systems. I don't think I need to state that again. Okay, and then finally, just to return to this idea of why rainforests especially are vulnerable. They're not resilient. They occur close to the equator where conditions are generally stable, and they've evolved in these kind of stable conditions. So species are not adapted for very rapid change on a huge scale. They begin with very high biodiversity, and the species can be very rare. The niches can be very specialised, and that makes repopulation very difficult if those niches are rare to begin with. Unfortunately, humans exploit rainforests to a huge extent, and the natural capital in rainforests is in huge demand. For example, I've said the timber, soya plantations, deforestation for beef ranches, and unfortunately, even the environmental movement has some responsibility for that. Deforestation, especially in Brazil, to produce biofuels. Together with the United States, Brazil is one of the 2 countries that produces more biofuel than any other country on Earth. if we go back to succession occurs over a very, very long time, very, very slow growing species. Therefore, it takes a very, very long time, hundreds of years potentially, to get back towards a climax community. And again, I've said this already, because of the very poor nutrient poor soils, thin soils in rainforests. Once you take away root systems from rainforests, erosion can occur very, very rapidly, and you can lose the soils completely. Basically, the nutrients are not stored in the soil, the nutrients are stored in the living material of the rainforest itself. And I've just said the only other ecosystem that we can really compare to rainforest is coral reef ecosystems. And I actually want to look at the Great Barrier Reef as one of our case studies of a threatened ecosystem. Okay. One or two more things just to finish. First of all, we can have these big biomes with differing biodiversity, but we also have these small hotspots of biodiversity around the world. Possibly the most famous that I know we've talked about before is the Fynbos area near Cape Town in South Africa. It's just a biological oddity where you find species that have evolved in isolation over millions of years, and they don't really occur anywhere else on Earth. So this tiny patch of land, the size of a few football fields, is home to about 2,000 species of flowers, and most of those don't occur anywhere else on the planet. Okay, and then the last thing that I've mentioned before, and I do want to discuss quite a bit in class, is the IUCN Red List, the International Union of Conservation. Every year they produce this red list of threatened species that are threatened with extinction. Obviously, it used to be a paper publication, but now they publish online, and I've just looked at the website just before I came to make this video. The URL is the IUCNRedList.org. I took a look just before recording this, and at the moment, the IUCN states that there are currently 38,500 species on the list, i.e. threatened with imminent extinction. And again, quite depressing, 41 species of all amphibians are now under threat of extinction. And something that came to my attention fairly recently, actually, sharks are really under threat. 37% of all sharks and ray species are currently threatened with extinction. I would encourage you to go to that website, please, and take a look for yourself. Have a look at the species there actually are on the red list at the moment. I guess one thing about the being online now is it's not updated once a year, it's updated constantly. So at least we have a better idea of the species that actually are under threat. The things that the IUCN takes into consideration when putting species on the red list are, well, I've listed them here. I was going to give you case studies of each of this, but it's not really necessary, and I will do a second video or maybe a third video about specific case studies, specific species. Maybe I can just mention a few here. So conservation status, or basically the threat that these species face, is based on, well, first of all, the size of the remaining population, that's obvious. The size of the remaining genetic diversity. You can have a fairly large population, but if the genetic diversity is very low, that species does not have a good chance of recovery. How narrow the niche is, or how specialised it's becoming. We already talked about these species that are coming close to being evolutionary dead ends. Those species that have become over-specialised, if that's a correct term, find it very hard to hang on, especially under threats created by humankind. Reproductive potential, how easy it is to breed those animals. Some species are notoriously difficult to breed in captivity, for example the giant panda. Two separate points here, but they kind of merge together. Distribution, geographic range, and possibly not just their range, but how the range has been fragmented or islandized. Famous example here is the axolotl of Mexico City. It only ever existed, well, during human history in two places in Mexico City, Xochimilco and Lake Chalco. And within the last 2 to 3 years, Unfortunately, it's been declared functionally extinct. It was only ever endemic in a very, very small place. It does still exist on the planet in zoos and laboratories. You possibly remember that the famous thing about this axolotl species, salamander species, is that it can regrow limbs once they've been chopped off. So it's a medical marvel that is being studied for possibly for human use or restoring human limbs. The quality of habitat. If the habitat is already under threat from humankind and it's becoming worse and worse and harder for those species to hang on, including possibly becoming islandized, then it's going to be difficult for that species to recover. At the trophic level it occurs on, you'll remember that the higher trophic levels are generally, it's easy to threaten them, or animals at higher trophic levels, top predators especially. One, they tend to have large territories, so therefore they're kind of smaller in number in the first place because of the resources available. Less energy is available for less and less organisms at the top of a food chain. And then also you might remember that the other thing that threatens animals at the top of the food chain is biomagnification of polar pollutants, polar compounds, as they move through the food chain. The famous example there would be the bald eagle in the US, which was heavily affected by DDT from the early 1950s onwards. Okay, and then finally, the IUCN takes all of these things into account, calculates probabilities of extinction, and makes a decision which species should go onto its red list. Unfortunately, year on year, the red list grows and grows and grows. And I think I already said, at the moment, I just checked, there are over 38,000 species on the red list. Maybe just going back to what I said right at the start, remember that we don't even know how many species are on the planet. So maybe that makes it very difficult to actually come up with a convincing list of how many species actually are under threat. But I do think the IUCN does a great amount of work. But again, it does make very depressing reading. Okay, thanks for your attention, everybody. Take care, and we'll discuss this further in the classroom.